My name is Ken Kohler. I'm the president and CEO of Advanced Ceramic Fibers. We're a small business located in Idaho Falls, Idaho. Our company is an advanced materials company, and what we do is we extend the performance utility of carbon fiber so it can be used in extreme environments. Extreme environments might include hypersonics, space exploration, turbine engine components, and that sort of thing. So our materials take a very high temperature environment, up 3,000 degrees Fahrenheit, and those temperatures, most other materials fail. And all materials fail at some level, at some temperature or strength. So we maintain the strength of the carbon fiber while at the same time adding value to the fiber by putting an advanced ceramic matrix material on the surface of the carbon fiber so that it can withstand those kinds of temperatures while still retaining the strength of the carbon fiber. So our material then could be used, we call it fibar, because it's fiber that acts like rebar in materials. And this fibar can then be incorporated into a ceramic matrix composite, which we call our Quad XE. And Quad XE is basically a ceramic matrix composite that can be incorporated into various material components like our fasteners, our high temperature, high performance fasteners for those hypersonic applications. It can also be used for turbine engine components, for all kinds of either commercial or DoD type turbine engines, which makes them operate at a higher temperature, which gives them more speed. And so we're always looking to increase the capability of our warfighters, and having an aircraft that has a high temperature, a higher temperature operation than the bad guys is always good for our pilots. So that's essentially what we do. We have a very interesting process for how we make our fasteners. They're non-metallic. There's no machining associated with it. We formed our fasteners with a mold. This mold is very simple, and our material, like I said, is non-metallic. It doesn't require any machining. So the manufacturability of this material, of this fastener, has a very high throughput, and it's very cost effective, much cheaper than most metal fasteners, especially anything that are used for very high extreme temperatures. So that's basically it in a nutshell.
What did you do to get ready for the conference today?
Oh, I did lots of stuff. I used the marketing report that was provided to me by my business consultant and his associate, and which listed all the potential contacts, either on the government side of the house, which is Navy, Air Force, Army, whatever, particular contacts that may be interested in what we're doing. And I sent out invitations to each of those people, asking them to participate and come visit the booth. And then I also went to the STP site where the Connect is located. And in Connect, it lists also other individuals, their names, their specific names, their phone numbers, and emails to identify whether they'd be interested in coming by the booth and seeing examples of our fibers and our fasteners. So I'm expecting a lot of visitors, hopefully, and we've really taken advantage of what's been provided to us by the support staff, John Ruhi. So he's provided a lot of support, been very helpful. So it's just a question of matching up with the people who are interested in our fasteners and other technologies. So we have other technologies we want to talk to folks about too that have to do with specialty materials. So